5.2, an introduction to quadratic functions. I guess I should have just put a blank sheet in you guys' notes, but we don't really have anything for this because I just want to introduce a couple things. Some of these we've seen already, some of this is new, and this is mostly just to get you ready for the rest of it. So let's talk about the word quadratic. So the word quadratic for us is going to mean that we have an x squared somewhere in our function. Okay, so that could look many different ways. So this is a quadratic function, and it's a fairly nice, clean-looking one. But quadratics could look like this. If we have an x squared, we could have something with an x, and we could have a normal number. So now we have three parts. So that's a trinomial. So that's one reason we did a lot of trinomial work. And sometimes they're given to you maybe in a form like this. Okay, and although this one doesn't look very nice right now, that's not a horrible way to have the equation given to you. Okay, so both of these fall more into the form of the general form. So that's more of the general form of a quadratic. And at some point we're going to end up calling this one the vertex form of a quadratic. Okay, and what those things mean we'll talk about later. Let's look at y equals x squared plus 5 because it's the cleanest of the ones that I have. So if I ask you to graph it, and you don't really have many tools in your belt right now to do that, one way that you could do that is, well, you could make a table. Okay, so this works for any function. So if you use, let's say we use 0, 1, and 2, let's see what happens. So we get 5 here, and here it's 1 plus 5, so that's 6, and 2 squared is 4, and 4 plus 5 is 9. So I have 3 points. Now, I'm going to graph that, but I want to think about what we know so far graphically about quadratics. So we've seen a lot of these, and we've used this graph, or this graph a bunch. We used this graph, or these two graphs, when we were trying to solve quadratic inequalities. So we know that the picture from this should look like one of these two. Well, do I get that? Well, let's just check. So I just have positive values, right? So I don't need any much in the negative side. So 1, 2, I need to go up to 9. 3, 4, 5, 6, 7, 8, 9. We'll go one more, and I only go over 2. So at 0 you're at 5. So 1, 2, 3, 4, 5. At 1 we're at 6, and at 2 we're at 9, and I made it go up to 10, so that's one less. So I can definitely see some sort of curve, but is that the lowest point? Or does it continue, and is the lowest point over here? So right now we don't know enough about quadratics to really understand that. So if you graph a quadratic, often you will need more than 3 points. Okay? I mean, with 3 points, it's very rare that you can graph it. So occasionally you can, but it have to be very specific 3 points, and I don't have those. Okay, and this is the how to read the quadratic. This is one of the skills that we need to learn. So what I mean with the how to read the quadratic is this. If I look at y equals x squared plus 5, I can tell you a couple things about this quadratic based on the format of the function. Okay, I actually do know that 5 here is going to be my lowest point, so that is my lowest point. And then there's some other properties of quadratics that would actually allow me to graph it based on the fact that I know these 2 points, because that gives me some more information about the quadratic on the other side. And we can sort of figure that one out. So quadratics are symmetric, right? And if I told you that this is the lowest point, then this point should mirror over here, and this point should mirror over here. And see, now I actually have 5 points, so we can actually finish this quadratic if we know that this was the lowest point, which at some point you'll be able to tell. However, that doesn't work for this one at all. So this one is a completely different way of graphing. You can't just look at this and say, well, the negative 1/3 is the lowest point. It's not. And the same thing is over here. That 8 has something to do with the lowest point, but it's not going to be at 0, 8. Okay, this one is in vertex form, and that means something completely different. So this is what we need to figure out, is how can we read these equations so that we can find enough points to graph it. So sometimes we do it through a table, and sometimes you can actually do it completely based on the function. The last thing then I want to introduce or look at again is intercepts. So when we did straight lines earlier, I said, well, just plug in zeros. That still works. So let's look at this one, x squared plus 5. And we actually have the graph now over here. So this is the appropriate graph. So if you plug in zeros, if you say x is 0, then you get y equals 0 plus 5 is 5. So 0, 5 was on the graph, which is this point right over here. Then if you plug in 0 for y, you get x squared plus 5 is 0. So you would get x squared equals a negative 5. So x would be plus or minus the square root of a negative 5, which is plus or minus the square root of 5i. And that's supposed to represent my x-intercepts. Well, sometimes it could represent 2. So those are either my x, that is my x-intercept, or if I get to my x-intercepts, and they're imaginary. And we saw that earlier in this year that imaginary intercepts can be graphed. So look, this one does not cross the x-axis anymore at all. So this makes sense. We should have imaginary intercepts for that one. Let's look at one more of those forms. So we'll take the fraction out, but let's look at x plus 1 squared, and then, what did I say? I said plus 8 there, right? So let's do plus 8 again. And there was a negative fraction, so we'll make this a negative. Okay, so I didn't want to deal with the fraction. So what happens here when you plug in zeros? Well, x0 still works out pretty well. So we get a negative, and then 0 plus 1 squared plus 8. That's 1. 1 squared is 1, so that's a negative 1 plus 8. So there's an intercept at 0, 7. How about y is 0? Well, 0 is a negative x plus 1 squared plus 8. Well, this is set up perfectly for completing the square. In this case, you have a negative chunk here, so I'm going to add x plus 1 squared on both sides as a chunk, or as a factor. So I get x plus 1 squared equals 8. How do you get rid of a square? Well, square root it. So hopefully you're looking at this and thinking, well, this looks like completing the square, which it really is. We have a perfect square here, so use it. So it's plus or minus. Don't forget the plus or minus. So the x-intercepts will be, so there are 2, negative 1, plus or minus, and then 8 breaks down, right? And some of you have seen this enough that you already know this, but 8 has a double 2 in it, so it's 2 square root of 2. So it has 2 x-intercepts. It has one x-intercept at a negative 1 plus the square root of 2, and it has one intercept at a negative 1 minus the square root of 2. Now graphing that would be more difficult because we don't really know what the square root of 2 is, except that, you know, the square root of 2 is approximately 1.4-ish. So you could sort of approximate and say, well, this x-intercept would be just past 0, so maybe 0.4, and then this x-intercept would be just a negative 1 minus 1.4 would be a negative 2.4, just past a negative 2 to the left. And you could use that if you wanted to, but there are better ways of graphing this. But finding the intercepts should be possible based on some of the skills that we've already developed up to this point. Okay, you are actually at this point ready, if you want to go ahead and work a little bit on functions of the form y equals ax squared plus q. So this is in your packet, and if you look for this worksheet, well, that's not going to work, is it? Because I wrote slanted. So, but that worksheet is in your packet, so if you want to start on that, feel free to do so.